In this video, we're going to start Chapter 5 on applications of integration. So applying all the things you learned in Chapter 4. So Section 5.1 is on consumer and producer surplus, price floors, price ceilings, and deadweight loss. So those are some applications that we're going to talk about. So our objectives in this section, given a demand and supply function, find the consumer surplus and producer surplus at the equilibrium point, and find the deadweight loss for consumers and producers when a price ceiling or floor is imposed. So these are economic applications. All right, so our first definition, suppose that you are given a function P equals d of x describes the demand function for a product. Then the consumer surplus for Q units of the product at price P per unit is the definite integral from 0 to Q, so that upper limit is your Q units of the product, of your demand function that will be given with respect to x minus the product of the units of the product and the price per unit. So graphically, if this is our graph of our demand function, that typically will be a decreasing function. Units of the item or of your product is your horizontal axis, so there's the Q. Price is your vertical axis. So here's the p-value. So this point on your demand curve, that ordered pair PQ, the product of those numbers is this part of your formula. And then otherwise you're finding the definite integral of that demand function starting at 0 up to this Q. So basically that value is, this first part is the area under the curve, the demand function between 0 and Q. But then if we subtract out the area of this rectangle, which is what this would represent, then you get your consumer surplus value to be the area of this little section right here that's in dark orange. All right, our second definition, suppose that P equals S of X is the supply function for a product. Then the producer surplus, Q units of the product at price per unit, is similar, but here we're subtracting in the opposite order and we're integrating our supply function. So Q times P again, but here we start with that, subtract the definite integral from 0 to Q of your supply function with respect to X. So your supply function will typically be an increasing function. The ordered pair QP right here at Q units at price P per unit is right here on the curve. So if you find the value of Q times P, that's the area of this big rectangle, and then if you subtract the definite integral from 0 to Q of your supply function, you're subtracting out this yellow area, leaving you with the green shaded region as the value of producer surplus. Okay, so in consumer surplus, you're going to integrate your demand function and subtract QP, and in the producer surplus, you're going to take the QP and subtract the integral of your supply function. All right, the equilibrium point is the ordered pair X sub E, P sub E, is the point at which the supply and demand curves intersect. So typically we'll want to be finding producer and consumer surplus at the equilibrium point. This is the point at which sellers and buyers come together and purchases and sales actually occur. Okay, so here are the two graphs we just talked about put together on the same grid. So here's your supply increasing function, the demand decreasing, the place where they intersect is here. Remember, this part was consumer surplus and this part was producer surplus, right? So if you put those two things together right here, right at that intersection point, that equilibrium point would be where they would intersect. Okay? So when you're calculating them, this X value right here is your Q, right, on your horizontal axis. All right, so let's look at an example. Given the demand function x minus 5 quantity squared and the supply function x squared plus x plus 3, we want to find each of the following. A, find the equilibrium point. B, consumer surplus at the equilibrium point. Part C, producer surplus at the equilibrium point. Oops. All right, so those are the three things that we've just talked about, so we're going to look at an example of how to do that. All right, so to find the equilibrium point, we set d of x equal to s of x and solve. So those were the two functions we were given for d and s. Set them equal. First thing we'll do is FOIL out the x minus 5 squared. If you subtract x squared from both sides, it goes away. Move the 10x to the right, so adding 10x to both sides gives you 11x over here, and then subtracting the 3 leaves 22 on the left, and then divide by 11 gives you x equals 2. So if x value of the equilibrium point is 2, to find the p-value of the y value of the equilibrium point, you're going to substitute that number you got for x into either of those supply or demand curves, right? Because they're equal at that point, so it doesn't matter which one you plug that 2 into. So they're going to use D. So if you plug the 2 into your demand function, that was the x minus 5 squared, so 2 minus 5 squared, negative 3 squared is 9. Remember, the y value of those curves is price, that is $9 per unit. So the equilibrium point, 2 units, $9 per unit is the ordered pair. All right, consumer surplus at the equilibrium point. Okay, so we're going to calculate the definite integral from 0 to our q. Our q is our equilibrium point of the demand function, and then subtract the product of that ordered pair that we just found, right? We found x equals 2 and the y value was 9, so that's the QP piece. 2 times 9, so that's the 18 back here. My antiderivative here is x minus 5 cubed over 3. Evaluate between 0 and 2. So we plug in the 2, plug in the 0, and subtract. So that's going to give us negative 3 cubed is negative 27 over 3. Negative 5 cubed, that's negative 25, but times a negative again is plus 25 over 3 minus 18, and all that together should be 44 over 3. Okay. All right, part B, consumer. This should be actually part C. Or no, I'm sorry. 44 over 3 converts, and we're still on this part. 44 over 3, remember we're talking about a price, so we would convert that to a decimal, which is 14.67, $14.67. We would want it in terms of money. All right, part C, producer surplus at the equilibrium point. All right, so this is where we start with our product of that ordered pair from the equilibrium point, being x was 2 and y was 9, so 2 times 9 comes first here, and we subtract the integral from 0 up to that x value 2 of my supply function. So we get 18 again for the 2 times 9. Here be careful here because you're going to do your antiderivative and evaluate, but you have a negative sign in front, so make sure when you're calculating this that you keep the negative in front of the whole thing. So x cubed over 3 plus x squared over 2 plus 3x is your antiderivative. And then you're going to plug in 2 everywhere and then subtract, plugging in 0. Technically, you would really want to put a big bracket around all of this because of the negative sign in front, but this is all going to be 0 anyway, so it won't matter here, right? Because this is a 0, so otherwise you got 8 over 3 plus 4 over, that should be a 2 right here. They have a typo there. 4 over 2 plus 6, and then all this is a 0. And then I would check here, let's see, if you were to, I think the answer, let me see here, you didn't catch this earlier. So 8/3 plus 4/3, it should be 8/3 plus 4 over 2. So 4 over 2, if this was, I think this answer is still right. If this was a 2 on the bottom, 4 over 2 is 2 plus 6 is 8. So you get 8 plus 8/3, and if you subtract that from 18, I think you still get this 22/3. So there's just a typo in the work. All right, and then 22/3, it translates to, as a decimal, $7.33. All right. So here would be a good time if you wanted to try that again on your own. This is a very similar problem to what we just did. Given a demand and a supply function, find the same three quantities that we just did in the last example. So if you want to pause the video, try to do this one on your own, and then you can press play when you're finished to see if you've done it correctly. All right, so we have a demand and a supply function given. Find each of the following, assuming x is less than or equal to 5. So we need equilibrium point, consumer surplus, and producer surplus at that point. Okay, so again, the equilibrium point is found by setting the two functions equal. So here they just moved everything over to one side. So 1 minus 1/3 is the 2/3. -6 minus 4/3, 7 1/3. And then 16 minus 4 is the 12. And then they cleared out the fractions by multiplying everything by a 3. I probably would have done that first rather than keep the fractions in that first step, but either way, we should get to here. All right, from here, we could factor. An easier way to factor this also, they just factored with these numbers. I would have probably divided everything by 2 first, just to make the coefficients smaller. And that's, if you did that, this factor would have turned out to be x minus 2 instead of 2x minus 4, but it's going to be the same answer in the end. So you would still get your solutions to be x equals 2 and x equals 9. All right, now remember at the beginning of the problem it said assume that x was less than or equal to 5. So that means we eliminate the other solution that we got 9. So that's why that was given. So we only have one. We can only have one equilibrium point. All right, so we're going to take our 2 that satisfies the condition that x had to be less than or equal to 5 and use it to find our p sub e, or our y coordinate for our equilibrium point. So I can take that 2 and plug it into either of those two functions. So again, they were choosing D to plug that into. When they plug that in, they get 2 squared minus 6 times 2 plus 16. So 4 minus 12 plus 16, or 8. So the equilibrium point is 2 units at $8 per unit. All right, consumer surplus. This is the one where we integrate from 0 up to the x value of our equilibrium point, the demand function, and then subtract the product of the components of that ordered pair. So we had a 2, 8 was the ordered pair we got. So 2 times 8 back here, and we're going to integrate 0 to 2 of the D function. So there's my antiderivative. The 16 comes from the 2 times 8. Plug in 2, plug in 0, subtract. Clean it up. $6.67. Okay. Producer surplus, this time we find the product of the ordered pair first and subtract the integral from 0 to our x value of our supply function. So there's the setup. There's the antiderivative. 16 is the 2 times 8 minus, and then the antiderivative of our supply function evaluated between 0 and 2. Plug in 2, plug in 0, subtract. Clean it up. $4.44. Okay. All right. Next definition. A price ceiling is a price, P sub C, such that that price is less than the P value of the equilibrium point, the y coordinate of your equilibrium point, and P sub C is the maximum price for which the product may be sold. That's called a price ceiling. The price floor, P sub F, such that that value is greater than your x value of your, of your y value of your equilibrium point, and the price floor is the minimum price for which the product may be sold. The loss in surplus is called the dead weight loss. All right, so our next example. In a small isolated mountain town, demand for propane is given by this function d of x, 650 minus 0.25x, and supply is given by 2.10 minus 0.15x, where x is in gallons per month per customer, and d of x and s of x are in dollars per gallon. All right, we're going to find our equilibrium point. We're going to find consumer and producer surplus at the equilibrium point, just like we did before. We're going to assume a price ceiling of $3 per gallon of propane is imposed, so that's the max price it can be sold for. And then we're going to find the point represented by the x value that gives us that price per gallon. So this $3 is the P sub C, right? And they're asking us to find the x. Then once we've done that, we're going to find the new producer and consumer surplus at this point. So using this point in our calculations instead of our equilibrium point, and then find the dead weight loss. Okay, this one is long. All right, again, equilibrium point, we set demand and supply functions equal. So those were the demand and supply that they gave us. Setting them equal, they moved here the x's to the right, so adding the 0.25 to both, or 0.25x to both sides, subtracting 2.10, and then dividing by the 0.4 gives me x equals 11. So we're going to find our y coordinate. So again, they plugged into either one of those you can plug into. They're plugging into D. Evaluate $3.75. So the equilibrium point is 11, 3.75. All right, consumer surplus then is definite integral from 0 to 11 of the demand function minus the product of the two components of that equilibrium point. So my antiderivative evaluated between 0 and 11. 11 times the 3.75 is the 41.25. Plug in 11, plug in 0, subtract. Use your calculator to clean it up. We should get 15.125. In terms of money, that would round to $15.13. Producer surplus, product of your equilibrium point components minus definite integral from 0 to the x value of the supply function. So if we get this time, it's 41.25 minus this definite integral. There's my antiderivative. Plug in 11, plug in 0, subtract. Clean it up, we get 9.075, or about $9.08. All right, to find where the price ceiling, which was given, remember in the problem, being the price ceiling of $3, so P sub C, $3, intersects the supply curve. We set the supply curve equation equal to that 3. So supply equals 3. Solve for x. So they just subtracted the 2.10 from both sides, and when you divide by the 0.15, you get x equals 6. So that's the x coordinate that goes with our 3 that was given for the y coordinate. So our x sub c, p sub c would be the ordered pair 6, 3. So now remember that then they said find the new consumer surplus and producer surplus. So using that ordered pair this time. All right, so we're finding it over the interval 0 to 6, right? Because that was our x value. So 6 times 3 was the product of the two components of that ordered pair we just found, and we integrate from 0 to 6 of the supply function. So 18 minus the definite integral, evaluated between 0 and 6, gives me $2.70. Okay. The new consumer surplus, they're doing these in the other order from when we did them before, but 0 to 6, the demand function minus the product of the order pair from the price ceiling that we found. Antiderivative, subtract the 18, $16.50. All right, so the dead weight loss is the area bounded above by d of x and below by s of x over the interval 6 to 11. 6 being the x value from the equilibrium point, from the price ceiling point, and then 11 being the x value from the equilibrium point. All right, so to calculate dead weight loss, we're going to take the demand function minus the supply function and integrate over between those x's. So remember, this x came from our price ceiling that was given, and then the 11 was the x value, right, that came from our equilibrium point. So they cleaned this up, distributed the negative sign, combined like terms. Notice we get something similar to when we found our equilibrium point, right, because we were setting those equal then. Okay, but that's just cleaning that up. Finding the antiderivative and then evaluating between the endpoints. So we plug in the 11 minus, then we're going to plug in the 6. Notice here the big parentheses around all of that because of the minus sign in front. That's important. And we get 5. So $5. All right, so a summary here of what we've talked about in this section. A demand curve is the graph of a function, d of x, that represents the unit price, p, a consumer is willing to pay for x items. It usually is a decreasing function. A supply curve is the graph of a function, s of x, which represents the unit price, p, a producer is willing to accept for x items, and that is usually an increasing function. The equilibrium point is the point at which the supply curve and the demand curves intersect. The consumer surplus at the equilibrium point, that's where we integrate from, so consumer surplus, we integrate from 0 to the x value of the equilibrium, the demand function, then subtract the product of the components of the ordered pair from equilibrium. And then producer surplus is where we start with that product and subtract the definite integral of the supply function. Price ceiling is the max price for which a product can be sold. It's always less than the equilibrium price. The price ceiling intersects the supply curve at this ordered pair. To find new producer surplus, we just do the same producer surplus calculation with the new ordered pair. Consumer surplus, same thing. We use our definition of consumer surplus, but with this ordered pair. And then to calculate the dead weight loss, we integrate from the x value of your price ceiling to the x value of equilibrium, demand minus supply. Remember, demand is your larger curve because it was a decreasing curve. Supply is the smaller one because it was increasing, so that's why we subtract in this order. All right, if you had been given a price floor instead of a price ceiling, it would have been very similar. Price floor is the minimum price for which the product can be sold. It's always greater than the equilibrium price. The price floor intersects the demand curve at that given value, and then the place where it would intersect demand curve, so you would plug that number into the demand curve and solve for the x. The new producer surplus, product of this ordered pair, again, just using that definition with your supply curve here being subtracted. New consumer surplus, same definition, only with this ordered pair. And then dead weight loss, same process. Demand minus supply is what we're going to integrate from the x value of your floor function to the x value of equilibrium. All right, so that then is the end of section 5.1.